Okay, so welcome to section, oops, let me undo that. Section 1.1. So section 1.1, which is angle measure. Angle measure. And special triangles. Okay, so let's first consider the following. Actually, maybe I'll do it in a bit darker orange. So let's consider so what is a line? A line goes off in both directions infinitely. So we call line AB would be through points A and B. And notice the arrows are going off in both directions. So this is called line AB. So it goes through A and through B and has arrows in both directions. So the what we put on top is like a little line, arrows in both directions. So that symbol indicates line AB. So now let's consider half of a line. So we're just going off to the right, say, or to the left. Just pick one. So let's say this is point A where we begin, and then we go through point B. So half of a line is termed a ray. So this would be ray AB. And much like for a line, we annotate this not with a whole line, just with half a line. So we put the arrow through B because it's going off beyond B. So ray AB. And now let's consider two rays, one down here on the horizon and another up a bit. And they meet at the point, let's have A be up here. So A, then B at the corner here, and then C down here. So this is called angle ABC. So angle, which we annotate by something that looks like an angle. It's a bit less right angle than an L. It kind of looks like an L, but it's a bit smaller than an L as far as both sides. So that looks like an angle, and that's a symbol for angle. And then we would put ABC, meaning we could go to A, then to B, and then to C. The most important thing is that the corner B is in the middle. Okay, so definition. So then we use this color. So definition. So an angle, that's what we're defining. An angle is created when two rays coincide at a common point. So is created when two rays, which are half lines, so when two rays coincide at a common point. So in the above picture, that common point was B, and that point is termed the vertex. So the vertex of an angle is where the two rays meet. Okay, so let's note something about angles. So note. So angle measures are usually annotated with Greek letters. So angle measures, and by measures I mean values like 35 degrees, 70 degrees, etc. So why did I put an? It's angle measures. Measures are usually annotated annotated with Greek letters. Annotated with Greek letters. So alpha, beta, gamma, delta, etc. So for example, say we have, let me color code this. I'm going to call one ray like so, and another ray like so. And let's have the 3 points be A, B, and C as before. And then we'll have angle theta here. Okay, so the yellow ray, which is BC, the line to the right through C, is the initial side initial side, because that's where we start to measure our angle. Notice the arrow for the angle starts at the yellow side and then ends at the purple side. So the purple side, which is BA as a ray, is the terminal side. Terminal side. And in fact, I can move that up a line. I've got the space. So it's the terminal side. Let me move this up a space. Okay, we call this, well, let me say the measure of angle ABC. Actually, let me write the angle symbol a bit better there. Of angle ABC is theta, meaning its value, its numeric value, is a Greek letter theta. So, theta. And you'll notice that the arrow for theta is going in the counterclockwise direction. That's important. So note that positive angle measurement is done in the counterclockwise. So positive angle measurement is in the counterclockwise. CCW direction. Okay, so let's look at angle measure nomenclature. Let me get a better color. So angle measure nomenclature Okay, so first let's start off with angle theta being strictly less than 90 degrees. So this is called acute. If an angle is smaller than 90 degrees, you can think that it's cute because it's small, so acute. So the angle would be less than 90 degrees, something like so. So here's our angle theta here. But what happens if the angle is 90 degrees? So if the angle is 90 degrees, this is a right angle. So this is called a right. Let me write that. I think that sounds better. It's called right. Let me get rid of the Is called right. Okay, so a right angle, the way we annotate this is with something that looks like a square. So a right angle will be annotated with a little square to indicate 90 degrees. Okay, so next we're going to have an angle that's larger than 90. So let's say theta is greater than 90 degrees. So this is called obtuse. Obtuse. So an obtuse angle will be a bit larger than 90 degrees. So it'll look something like so. But what about, let's do a bit farther. Let's say that theta is 180 degrees. Well, this is called straight. Boy, let me draw that a bit better. It's called straight. So what's happening now is the angle of a straight line is 180 degrees. Okay, there's one more we can do. And that is when theta, the angle, is larger than 180 degrees. And this is called a reflex angle. So called reflex. So that's going to look something like so. That's a reflex angle. It's larger than a straight angle. Okay, so let's recall. Hopefully this is a recall. If it isn't a recall, then please learn it now. So recall. So the interior sum of the angles of a triangle in the plane is 180 degrees. So the interior sum of the angles of a triangle, angles of a triangle in the plane is 180 degrees. Okay, so now definition. So two angles, alpha and beta. So two angles, remember, their angle measures have Greek names. So two angles, alpha and beta, are termed and we're going to have two subscripts. So the first definition will be complementary. So that's our first definition. They're termed complementary if alpha plus beta is equal to 90 degrees. Alternately, they're termed supplementary. Supplementary if alpha plus beta is 180 degrees. So remember, 90 degrees is what? That was called a right angle. So that's a right angle. Their sum is a right angle. But 180 degrees, what was 180 degrees? That's called a straight angle. So this is called a straight angle. Okay. So there's a trick I use to remember these. Complementary starts with a C, and supplementary starts with an S. but C comes before S in the alphabet, and 90 comes before 180. So if I remember the order is the same alphabetically as numerically, then I know which is which. Okay, so let's do an example of this. So example, let's determine or find either the complement or the supplement. Let's do that. So find either the complement or the supplement. Complement or the supplement for the following. So number 1, the complement of, let's do alpha equal to 20 degrees. So what is the complement to that? Well, I know that alpha plus beta, let's have beta be pink, shall we? Plus beta must be equal to, well, since it's complement starts with a C, so that's before S, so their sum must be 90 because it's a smaller. So what was the given angle for alpha? Well, 20 degrees plus whatever beta is must be 90. So subtracting 20 degrees from both sides, I claim that beta is going to be 90 minus 20, so beta is 70 degrees. So the complement to 20 degrees is 70 degrees. Let's see if I can move this up a line. Is that too cramped or is that okay? Maybe that's okay. I think you can read that. Okay, so number 2. Let's find the supplement. So the supplement of, let's have beta this time, be given as 120 degrees. Okay, so I know that alpha plus beta, well, supplement starts with an S, so that's after C, so I know that this supplement sums to 180. Okay, so I have alpha plus the given angle beta is 120 degrees, and that should sum to 180 degrees. So if I take away 120 from 180, I'm left with alpha equal to 60 degrees. That's a terrible looking alpha. Let me make that a bit better. So there we go. So that is the supplement to 120 degrees. So now let's look at special triangles, and this is very important to the whole semester. So special triangles. Okay, so let's recall. So given a triangle, or given, how do I want to say this? So given a right triangle, meaning one angle is a right angle, or 90 degrees. So given a right triangle, and let's annotate this, triangle ABC, with opposite sides, little a, little b, and little c respectively. We have that. the Pythagorean theorem. The Pythagorean theorem states that okay, so let me draw a picture first. What are we talking about? We're talking about a right triangle. So it's got a right angle somewhere. Let me draw this little right angle a bit better. Okay, so this is triangle ABC. That's A, B, and C with opposite sides, little a. Actually, do you know what? I'm going to put C at the vertex. It'll be easier. So let's do B up here and C at the vertex. Okay, so with opposite sides, little a, little b, and little c respectively, I wanted little c to be the hypotenuse. So the Pythagorean theorem states that the sum of the squares of the legs, so that is a squared plus, actually let me do this in pink, plus b squared is equal to c squared. That's a Pythagorean theorem. And of course, c in this case is the hypotenuse. And the hypotenuse is always the longest side. So let's consider let's say I have a triangle with two sides that are the same. Let's see, 1, 2, 3, 4 boxes, 1, 2, 3, 4 boxes. So something like so. I want that both the sides have the same length. And of course it's a right triangle. And let's call the length of the sides, let's call it S. So this is side S. Oh, side S, because they're the same. And then I want to find the length of the hypotenuse. Let's call that H. Well, since I've got a 90-degree angle right here, and I know that the sum is 180, I have to split 90 degrees between the other two, which gives me 45 degrees and 45 degrees. Okay, using the Pythagorean theorem, actually let me make the angle so it looks a bit better. So the Pythagorean theorem states that h squared, the hypotenuse squared, is equal to the sum of the squares of the length of both sides. So in this case, a squared plus b squared is s squared plus s squared. And c is the h that we have here. So we get that h squared, h squared is going to be 2 s squareds. So 2 s squareds, because if I have 1 s squared plus 1 s squared, and I add them together, I get 2 s squareds. So now let's take the square root of both sides. So I have that h is going to be equal to the square root of the right-hand side. So that's going to be the square root of 2. But of course the square root of s squared is just s, much like I saw for h on the left. Okay? So, actually let me move this down a line so it's clearer. So the hypotenuse is going to be the square root of 2 times the length of the side. So let's note, what type of a triangle was this? So in a 45, so in a 45-45-90, so those represent the angles from smallest to largest. But I have two of the same smallest, so in a 45-45-90 right triangle, the ratios of side to hypotenuse, so the ratios of side to hypotenuse, so side to hypotenuse, are given by okay, well, it looks like we have side S to side S, because both sides are the same length, to hypotenuse. The hypotenuse had length the square root of 2 times S. Square root of 2 times S. Okay, so whatever S is, this is the ratio. So what I'm going to do, I'm going to divide off by what's common to all three. So let's divide all three parts of this ratio by S. So I divide all three parts of this ratio by S. So the S's reduce in each part of this ratio. So what I get then is S over S reduces to 1. So 1 to 1, of course, because S over S once again reduces to 1. To, oops, those are colons. To, well, I'll just have root 2. So I'm just going to write this as square root of 2. So these are the ratios. Let me put a box around these. These are the ratios in a 45-45-90 right triangle, and these represent side to hypotenuse. Okay, so once again, I'm going to consider a different type of a triangle. So let's consider. So let me use this color. So consider. So now I'm going to consider an equilateral triangle, meaning a triangle with equal sides. Let's see if I can, no, it's not going to let me. Let's see if I can autocorrect to an equilateral triangle, maybe. Let's see. 1, 2, 3, 4, 5 is my base. 2.5. Yeah, that looks almost like an equilateral triangle. So let me copy and paste this for later. Okay, so in an equilateral triangle, I know that each of the interior angles, their sum is 180 degrees, so divide that by 3. Each of the angles must measure 60 degrees. Okay, and each of the sides, let's call it, oops, what have I done? I need to erase that little bit there. So let's call each of the sides 2S, just for convenience. You'll see why in a moment. So what I'm going to do now is I'm going to take this equilateral triangle, and I'm just going to cut it in half vertically. So now I'm going to have an altitude drop down at a 90-degree angle. So this is still 60 degrees down here, but on top I've divided 60 by 2, so the top angle is now 30 degrees. Now that's a bit hard to write, 30 degrees. Okay, but the hypotenuse now, this is 2S, but half of one side is S. So what I'm going to do now is take just that right-hand triangle. So let me paste this again. So what I'm going to do is I'm going to drop the altitude or height, and I'm going to erase this side because now I just have the right-hand triangle. I know that this is a right triangle with one base angle of 60 degrees and another angle of 30 degrees. I don't like the way that 30 looks. Let me make that a bit better. Let's zoom in here, 30 degrees. Okay, I know that now the hypotenuse of this is 2s, the base is s, so I just need to find the height h in this triangle. So that's what I'm going to do now. Well, using the Pythagorean theorem, we know that h squared plus s squared is equal to the square of the hypotenuse, which is 2s. So I get that h squared plus s squared well, 2 times 2 is 4, and s times s is s squared. Okay, so now what I'm going to do is I'm going to subtract s squared from both sides. So I have 4s squared minus 1s squared. Leaves me with 3s squared. Then finally I'm going to take the square root of both sides. Square root of something squared is just itself. So I get that h is equal to the square root of, well, the square root of 3 is just square root of 3. I can't simplify that. The square root of s squared is just going to be s. Okay, so that's what the height is. So let's note now. Let's note. So what type of a triangle was this? This is called a 30, 60, 90 right triangle. Actually, maybe I should move this to underneath here so we know where that's coming from. Okay, so note in a 30, 60, 90, a 30-60-90 right triangle, the ratio of short side to long side, so here that would be the base to the height to the hypotenuse. So the ratio, or the ratios of short side to long side to hypotenuse is given by okay, so what do we get? We get s. So we had s. Then we had root 3s. I'll just copy and paste that. Square root of 3 times s. And then 2s for the hypotenuse. But of course I'm going to divide each of these by s, because s is in the way here. Actually, let me divide it by this color. So let's divide each part of this ratio by s, which is a random variable, so s over s reduces to 1. So this ratio becomes 1. Well, in the second part of the ratio, it's just root 3. And the third part of the ratio is 2. Okay, so let's put a box around this so we see this as well. Nope, okay. Okay, so for example, let's finally do examples with this. Make that box a bit smaller. So for example, so let's find the missing sides in each scenario. Or let me put it this way, find the measure of the missing sides in each scenario, or in each of the following. Okay, so number one. Let's say we have a 30, 60, 90 right triangle, something like so. Note, not drawn very well. So let's say we've got 30 degrees down here, 60 degrees up here. And let's say we have, let's do 6 for the hypotenuse and 3 root 3 for the long side. So this is a 30, 60, 90 right triangle. So I know that I'm going to use the ratios 1 to root 3 to 2. 1 to root 3 to 2. So let's copy and paste that. But before I use this, let's note that this corresponds to what? This corresponds to 1 would be the short side. Then root 3 would be the long side. And then 2 would be hypotenuse. So that's the ratio there. Okay, so I'm going to use this ratio, and I'm going to ask myself, well, what do I know? I know that the hypotenuse measures 6. So how do I get from 2 to 6? What should I multiply this ratio through by in order to get to 6? Well, 6 times 3 would be 2. Sorry, 6 times 2. Oh my goodness, what am I saying? 2 times 3 would be 6. Okay, I should not record when I'm so tired. Okay, so now I'm going to distribute the 3 to each parts of this ratio. So what that gives me then, 1 times 3 is 3. 3 times root 3 is simply 3 times root 3. There's nothing I can do there. And then distributing, 2 times 3 is 6. Okay, so I got the right hypotenuse. I've got the right long side, so it looks like the side that's missing, the side I'm looking for, is 3. Okay, so that's the side I'm looking for. It has a value of 3. Okay, let's do another one. Number 2, let's say we have a 45, 45, 90 right triangle. Okay, so 45 degrees, 45 degrees. Let's say I give you the length of the sides are 3. Now let's give it in purple, so 3. So the missing side, of course, is the hypotenuse. So the ratios for the 45, 45, 90 are 1 to 1 to the square root of 2. So we know the ratio should be 1 to 1 to the square root of 2. And of course that's going to be side to hypotenuse. Actually, let me side to hypotenuse. so we just take this ratio and we ask ourselves, okay, I know that the length of each side was 3. So how do I get from 1 to 3? I would need to multiply through by 3. So I multiply this whole ratio through by 3. Let me move this down 1. So I'm going to distribute the 3 inside to each part of this ratio. So what that gives me then is 3 to 3 to 3 times root 2. So that means that the missing side is 3 times root 2, and that's going to go right here. 3 times the square root of 2. Okay, let me move this up a bit. Okay, so let's see, where am I? Let's do another one, shall we? So number 3. Let's do another 30, 60, 90 right triangle, except let's orient it a bit differently. So let's say our 30-degree angle is up here, and 60-degree angle is down here. Let's say the long side is 2 root 3. And let's say, now what did I do up here? Okay. Let's say the hypotenuse is 4. So let's find the small side then. Okay, so what are the ratios in a 30, 60, 90 right triangle? Well, they're 1 to root 3 to 2. So let's copy that, 1 to root 3 to 2. And remember that corresponded to short side. To long side. To hypotenuse. Hypotenuse. Okay. So I've got the hypotenuse. I know the hypotenuse is 4. That's really all I need. So what do I need to multiply 1 by in order to, 2 by in order to get 4? Well, that would be 2. So if I distribute 2 to each part of this ratio, 2 times 1 is 2. 2 times root 3 is 2 times root 3. 2 times 2 is 4, and that's exactly what I had, so that works. That was my hypotenuse. My long side is 2 root 3, so it looks like the short side is 2. Okay, so the short side has a measure of 2. Okay, so hopefully this is making sense how you find the missing side in a 30, 60, 90 or a 45, 45, 90 right triangle. Okay, so now let's consider the following. So I'm going to create a box. Let's see, maybe I can make it big enough. Something like so. That might be a bit too long. Make it a bit shorter. So this is kind of a rectangular box, not square. And what I'd like to do with this box is I would like to have a triangle in here that looks like so. first I'm going to go down here, and then I'll go something like so, and then like so. So this is a triangle I'm going to have inside here. So what do I have? I have a 90-degree angle here, and of course I have 90-degree angles everywhere on the outside. Okay, so technically I have 4 triangles here. So I have a triangle down here in purple. It kind of looks like a 45, 45, 90 right triangle, which it is. So I'll call this 45, 45. But if I look at this triangle here, to the right, it also appears to be a 45, 45, 90 right triangle, because both legs have the same measure. Remember, these are degrees. Degrees. Okay. So, let's say that this guy here measured 60 degrees. Well, since the other measure inside the orange triangle is 90 degrees, because of that right angle, I know that the final angle will be 30 degrees inside here. Okay, so what I'm looking for is the angle measures in this triangle up here. Oops. Let's call this pink. Okay, well, I know that this would have to be a straight line. 60 plus 45 is going to be 105. So 105 and 75 would be 180, or a straight line. Okay, similarly over here, I have 30 plus 45 is going to be 75, plus 15 will be the 90-degree right angle up here. Okay, so that's 75 and 15 for the angle measures inside that pink triangle. Okay, let's suppose that I call the length of blue x. So this length here is x for this side. So that means that this length here is also x for this side. And let's have the purple guy be called y. So this is y to here. Since this is a 45, 45, 90, this is also y to here. Okay, so it must be the case that this guy right here, oh, oops, what have I done? Haven't made my arrows long enough. Sorry about that. It's hard to see. Once I take off the grid, you'll see how much nicer this will look. Okay, so the pink guy right here must be, this length must be larger guy, which is the whole side, minus the small part, y. So I have the whole right-hand side minus the purple left-hand side for what's left. Okay, and if I look at the top must have length purple plus blue if I look at the bottom. So that's going to be y plus x, or x plus y. So x plus y for the length of the top. So let me indicate that with arrows. So the whole length here. Okay, so hopefully this setup is understandable so far. Okay, so let's consider the orange triangle is a 30, 60, 90 right triangle. Okay, so What shall I do? Let's call this length 2. So the hypotenuse of a 30, 60, 90 right triangle, remember 30, 60, 90 is in the ratio of 1 to root 3 to 2. So if the hypotenuse is 2, I know that this longer side must be root 3 and the shorter side must be 1. Okay, so that's good. I don't need to do anything there. Just need to annotate that. Okay, what else do I know? Okay, what about the 45, 45, 91? Actually, maybe I'll bring this back down here. So for the 45, 45, 90 right triangle, let's do the blue one first. I know the ratio is in 1 to root 2. However, the hypotenuse of this 45, 45, 90 right triangle is root 3. So how am I going to do this? I would first need to divide everything by root 2 to get rid of the root 2. So let's divide all 3 sides by the square root of 2. And then I would need to multiply that by root 3. Okay, so what do I get when I distribute? I will have, if I don't rationalize, so let's see, let's not rationalize. So I'm going to distribute the square root of 3 to everything here. So what that's going to give me then will be, where's my blue? Will be the square root of 3 divided by the square root of 2. 2, the square root of 3 divided by the square root of 2. 2, the square root of 3. And that's what I have as the hypotenuse there. Okay, so the length of the sides are the square root of 3 over the square root of 2, but I don't like that, so I'm going to rationalize. So when I rationalize, what I need to do is I need to multiply each of these by what's in the denominator. So this will be multiply by root 2, top and bottom, to rationalize. This is 2 square root of 3 over square root of 2 times square root of 2 over square root of 2 to rationalize. And I'll just leave the last part of the ratio, square root of 3. Okay, so what I get then in the numerator is the square root of 6, all divided by 2. Square root of 6, all divided by 2. And square root of 3. Okay, so that means that x is equal to the square root of 6, all divided by 2. So now I have a value for x. So let's see if we can do the same thing for the purple guy. So we're going to start off with 1 to 1 to root 2. But I know that the purple guy, his hypotenuse is 1. So once again, I'm going to have to divide off by root 2. So let's divide everything by root 2. And then I'll be done, because all I'll need to do then is rationalize. Because note, root 2 over root 2 reduces to 1. So what I'll have then is 1 over root 2 to 1 over root 2 to 1. And the hypotenuse is 1. But in order to rationalize, I would need to multiply top and bottom by the square root of 2. So square root of 2 over square root of 2. to 1 over the square root of 2. Square root of 2 over square root of 2 to 1. Okay, so that gives us the square root of 2 over 2 to the square root of 2 over 2 to 1. Okay, I think we now have what y is. Y is the side, or the square root of 2 over 2. Square root of 2 over 2. Okay, so now let's find out what x plus y and x minus y are. Okay, so x plus y is x plus y is equal to, and x minus y is equal to. Okay, so what did we find for x? We found that x was root 6 over 2. So root 6 over 2, root 6 over 2. And in the first case, we're going to add. In the second case, we're going to subtract y, which we found to be the square root of 2 over 2. Okay, so x plus y will be the square root of 6 plus the square root of 2 all over 2, because they have a common denominator 2. And in the second instance, it'll be the square root of 6 minus the square root of 2 all over 2. Oops. Okay, so why did I do all of this? Okay, so I know that x plus y and x minus y. Well, if I look at that smaller triangle, which was what? It was a 75. So let me draw the triangle. It was pink, right? Something like so. That was that top triangle here. Here's our 90-degree angle. Here's, actually, let me write the angles in purple. So 75 and 15 degrees. And we just found out that x plus y, which is what's on top, is, oh, let me just indicate it here. And x minus y, which is on the side, is here. I don't like those arrows. So I know that this will be the square root of 6 plus the square root of 2 all over 2 for this long side. And the short side is going to be the square root of 6 minus the square root of 2 all over 2. So in a 15, 75, 90 right triangle, what do I have? So let me make sure that we know. So note, so in a 15, 75, 90 right triangle, we have that the ratio of short side to long side to hypotenuse is, okay, well, what was the hypotenuse there? The hypotenuse was 2, right? So we could write this as 2 is going to be, well, what was the short side? It's the square root of 6 minus the square root of 2 all over 2 for the short side. 2, the long side, almost looks the same except it's got a plus. So subtraction for the small side, addition for the long side. So square root of 6 plus the square root of 2 all over 2 to 2. And if you want to divide by 2 to make the hypotenuse 1, it doesn't matter. But there we are. So let's go ahead and put a box around this. Oh wow, that's not exactly what I was thinking. A box, it looks like a box. How about that? There we go. Okay, so hopefully this makes sense, and I will see you guys in the next section.